Hello, class. Welcome to the week 13 unit, which also happens to be the final unit in the course. So, where does the time go, right? We're almost at the end. In this final segment, we'll cover a data file that you'll commonly encounter if you do any sort of data analysis with any sort of meteorological data. So, that's going to be the main topic that we'll be covering during the course of this week. And that data file is called a NetCDF file, which stands for Network Common Data Form. And these are commonly used to store grids of meteorological data. Contrary to the beliefs of some, the Earth is in fact a spherical object, which means having a nice Cartesian table of values is not going to work very well for a lot of what you do. If you're working on a really small scale, then yeah, Cartesian will work just fine, but uh, unlike spreadsheets, which basically are designed to work for like nice Cartesian X and Y coordinates, spherical coordinates don't work so well in spreadsheets, which is why this data file was created so that we could work with a spherical coordinate and still have some data to work with in a nice spherical sort of framework. And again, these commonly store meteorological variables. So these data file that we're looking at specifically stores sea surface temperatures, but you can also have data files that store like air temperature, relative humidity, wind speed, other parameters like Keach Byram drought index, energy release component. Just about any meteorological variable at all can be found in just about any NetCDF file that you encounter. But the NetCDF file that we're working with specifically is in fact located on the server. So it's just to sort of give you a preview of what it actually look like to some degree. Just have to get onto the server. And this will also show you where exactly to find this NetCDF file on the server and what's so special about it. So in order to get to the NetCDF file, first you have to get into the server's home directory. So again, that's just cd followed by a space followed by a / to get into the server's home directory. And just to remind you what this looks like, there's our list of directories. And I'll just go ahead and tell you that the data directory is where our NetCDF file is located. So let's go into the data directory. Yeah, there's some other files and stuff in here, but this is the NetCDF file that we're going to be working with. And one of the things that should jump out to you is the file extension .nc. That is in fact the extension for a NetCDF file. So any file that ends in .nc is considered to be a NetCDF file of sorts. And again, this particular file works with sea surface temperatures, but to get the actual data, access to the actual data, that's something we'll cover in later segments. There's a couple ways that you can do that, and we'll actually look at both ways to get the data out of the NetCDF file or get more information about it. But if we want to see what it actually looks like, there's a command that we can type on the server called ncview. And then after that, we put the name of our NetCDF file. So that's TOS, all lowercase, underscore, capital O. This is in fact a capital O. This is not a 0. It's a capital O. Number 1, underscore, 2001 hyphen 2002.nc. And if we run that command, it brings up a neat little window that looks like this. And the way you actually get this will actually generate a plot of the data itself projected onto a globe. So if we want to see what that looks like, you click on the TOS and that pulls up this little window, and you can see here it generates a nice colorful plot. And these values, these pixels that are colored in white, that's in fact where data is missing. So keep in mind, this is sea surface temperature data. It's kind of hard to record a sea surface temperature measurement in, say, Beijing, China, or Houston, Texas, where there's land. So there's really no sea surface temperature to be recorded there. That's why some of these pixels are blank. But where there are sea surface temperature readings, you can see it does plot it in a bit of a color scale, and the color scale pops up on the left here. So this red here indicates very warm temperatures, 305 Kelvin. That is pretty warm. And then blue values closer to 270 Kelvin, which is below freezing. And you can actually get sea surface temperatures that are below freezing, and the reason why is because you have a lot of salt content. So if you take in chemistry classes and you learn about freezing point depression, if you dissolve a substance into a liquid, it effectively lowers its, or into water, I should say, it effectively lowers its freezing point. So that's how you can actually get water that is below the freezing point, but because it's mixed in with a lot of salt, like much of the water on this planet is, since it's mixed in with a lot of salt, that actually lowers its freezing point. And that's also the reason why in advance of an ice storm, road crews will dump salt on the roads because that lowers the freezing point and decreases the likelihood of ice forming on the road. So, a little bit of a chemistry lesson there, but that is how you can actually get sea surface temperatures below freezing on the Earth's in Earth's oceans. And if you mouse over here, it will show you. It will show you on the left-hand side of the screen what value is observed at the mouse. So right now it's 271.442 Kelvin. And then I can just sort of go on through here. And this is over a period of 24 months. So if I want to, I can step forward. You can see the sea surface temperatures evolve, and at some point I'll get to the maximum value, which is in December 2002. So anyway, that's sort of a look at what we're actually going to be working with. And there is a bunch of data that you can get into, you can get access to and perform some analyses on, but that'll be something we cover in the next segment. So with that, I will see you guys in the next segment.